In this lesson, I'll show you how to predict molecular geometries of ions. Question 1 reads, predict the geometry and bond angles of the molecule ICl₄, and this is a negative ion, as you can tell from the superscript. The first thing that I want to do is show you what the Lewis structure looks like. We'll have a central atom, I, and bonded to the central atom are 4 chlorine atoms. Chlorine has 7 valence electrons, and since we have 4 of them, we'll multiply 7 by 4. That gives us 28. Iodine also has 7 valence electrons, so adding another 7 to this, we'll end up with 35. Now, given that the molecule is negative, that means it has an extra electron, so this adds up to 36. According to the structure that we've drawn so far, we've used up 1, 2, 3, 4 times 2. That means 8 electrons. Subtracting 8 from this total gives us 28. So we have 28 electrons to work with, and we'll spread them around this molecule, starting with the peripheral atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. This means we have 4 more to work with, and those 4 will actually be lone pairs of the central atom. What you see on your screen right now represents the Lewis structure for this molecule. Next, I want to count the total number of bonding groups, and that constitutes the number of single bonds, double bonds, or triple bonds that are associated with the central atom. And that also includes when you have a single electron around that atom. So we have 1, 2, 3, 4 single bonds, and that means we have 4 bonding groups. Next, I want to determine the amount of lone pairs. We have 1, 2 lone pairs around the central atom. Adding this up, we end up with 6 electron groups. We'll now use this chart to see the molecular geometry. We'll focus in specifically on this part. We have 6, 4, and 2, and that's represented right there. This means that the molecular geometry here is a square planar, and it will have exact angles of 90 degrees. In addition, the electron group here is an octahedral. That answers question number 1. Let's move on to question number 2. In question number 2, we have to predict the molecular structure of triiodide, and it has the chemical formula shown on your screen. Just as before, we'll start with the Lewis structure, and this one is not that hard. In fact, we have 3 iodine atoms, and iodine has a valence of 7. 7 times 3 is 21, plus that extra electron, we have 22 to work with. We've already used up 4, so we have 18 to work with. I'll spread those around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and the last 2 will be a third lone pair around this central atom. So this is the Lewis structure for this molecule. Let's do the same thing as before. The amount of bonding groups here is 1 and 2, so Bg is 2. The amount of lone pairs, we have 1, 2, 3, and this tallies up to 5 electron groups. Using this chart, I apologize if it's small, we have 5, 3, and 2. 5, 3, and 2. That means we have a linear molecular geometry. That also means that this will be perfectly straight at 180 degrees, forming the electron geometry of a trigonal bi-pyramidal, if you're curious. And there you have it. 2 more examples on how to predict molecular geometries, namely of ions.